So what are we going to see today? So the following are the 6 things that you will learn today as part of this webinar. So what are the components of an edge AI vision-based solution? And we will go into each of these components, like how to choose the right camera for your application, then how to choose the right processor, and why Nvidia is the best processor for edge AI solution, and how to identify algorithms or models for your prototyping. Where do you start with your algorithms? So we'll also be touching on that. And how to accelerate. So once you know all these components, and when you start the development, how do you quickly accelerate your development? And when to work with a AI or an edge development expert, how to start your own development, and when you should reach out to experts. So we'll cover all this, maybe not in this particular order, but I hope at the end of this webinar, you will have answers to all these 6 questions. So let me right away start with the core components of an edge AI application. When I talk about a vision-based application, obviously the camera is the first part, and a camera is a very a subjective thing. So it's not a one-size-fits-all, and you always have to make the right choice of your camera. The second main component is the edge processor. Like I said, running a model or making an inference at the edge is a challenging task, and so you have to choose the right processor. So that's the second part. And the third is what kind of an algorithm that you're going to use, or what kind of a model that you're going to train and use in your edge application with all the limitations that you have on the edge. So these are the 3 different components that we'll be talking about today. And I will have my colleague Gomati Shankar, who's an expert in the cameras, to take over the webinar from here and explain you how you could choose your camera for your AI edge solution.
Thank you, Maha. Hello, everyone. This is Gomati. So image quality is a very critical for a vision-based edge AI system. So if you get a best quality image, then the life of an inference system is going to be simple. If the image quality is not good enough, then it is going to be hard for the application algorithm development. So what we would recommend is consider these 4 aspects when you choose the camera. We always look at the resolution of the camera, but that is just one aspect of the camera system. Whether we need a full HD or 4K or more than that, it is just one aspect. What are the aspects we need to consider when we choose the camera? What kind of optics we have to choose for application? We always look for the autofocus lens, but is it suitable for all the application? That is something we need to look for. What is the purpose of an image signal processor? Do we need an image signal processor for the application? What is a suitable interface for the camera? Let's see one by one. Okay, so let's look at one of the application. Like if assume your end application is an outdoor application, like smart surveillance or smart parking lot system or smart traffic system or any outdoor video analytic device. The first and foremost thing we need to consider is we are going to have harsh lighting condition. The sunlight make it right into the sensor. So if you choose a sensor with a high dynamic range, then that would be a perfect fit. The other things we need to consider for an outdoor application is, are we going to use these cameras in the night vision as well? When I say night vision, whether it is just a low light or we are not going to have any light at all. If it is a low light application, then we will have to choose a bigger sensor size that will provide better image quality at low light. If it is a smaller sensor size, then we are going to get a lot of noises in the low light. In other case, if there is no light at all, then the sensor has to support infrared region as well. So look for quantum efficiency in the infrared region. Let's assume another application where the end object, where the object is going to be moving really fast. Example, license plate recognition. If you use a rolling shutter camera, you may get into motion blur issue. You may not be able to read the number plate properly. Or if it is a AGV, automated guided vehicle, then again, rolling shutter may not be a very good option. You may need a global shutter camera, and we may need synchronization as well. So global shutter would be best for any moving object application. Let's assume another application, parking lot management. You may not need a high frame rate in a parking lot application because objects are not going to move really fast. But in case of industrial automation, one of our customers asked for 400, 500 frames per second in industrial automation. So if you are going to use it for industrial automation, go for a sensor which can support high frame rate. Resolution may not be a big deal at this point, but frame rate is a big deal. Let's look at the optics for these applications. If it is a facial recognition system or face detection application or any simple object detection application where the object is close enough, within a meter or 2 meters, then the autofocus would be a better option. But if the object distance is more than 2 meters, autofocus may not be a very good option. We have to look for a fixed focus lens where we get enough depth of view for our application. For smart surveillance, we may need a wider field of view lens, but when you choose wider field of view lens, look for fisheye effect, whether it is something you can manage in your application, or you will have to choose something like 10-100 degree where you may not get a lot of fisheye effect, but it will be good enough in the field of view. So these are some of the things we need to consider when you choose a sensor or optics. What is the need of an ISP? What is an ISP first? ISP is a hardware or a software block which is responsible for most of the auto functions, the auto exposure, auto white balance, auto focus. All these things are taken care of by the image signal processor. The image on the left is what you get usually from the sensor. With the fine-tuned ISP, you will get something on the right. If it is not fine-tuned well enough for your sensor, then you may not get a very good image quality, regardless of what sensor you're going to use. If it is a monochrome sensor, we may not need a full-fledged ISP. All we need is just an auto exposure, which can be handled in the software, or some of these monochrome cameras comes with an auto exposure inbuilt. But if it is a color camera, ISP is a must. And mostly, choosing an ISP is the most underrated thing. We underestimate the time consumption of integrating an ISP with a sensor, but fine-tuning an ISP is the most time-consuming work in the product development cycle. Also, getting an access to these ISP settings is not an easy thing. Preferred partners like us get access to Nvidia ISP. It will not be available for everyone. So when you select the camera system, ISP is a most important block. Then the next important part is the right camera interface for your application. Generally, sensors comes with MIPI interface. Then if you need it in an USB interface, this MIPI data has to be converted into UVC packets and send it across. Or if it is a GIGI, then you will have to make it as an IP packet and send it across. Again, for the GMSL, it has to be serialized and send it across. So MIPI is the natural interface of any camera system. So reliability-wise, MIPI is the most sturdy interface. When it comes to GMSL, GMSL can be used for a longer distance. When it comes to MIPI, it can be supported up to 30 to 50 centimeter. But when it goes for longer distance, like applications like fleet management, you may not be able to use MIPI interface right away. You will have to convert serialize the signals. You can use GMSL. Then in terms of bandwidth, MIPI provides higher bandwidth. Just to give an example, if you want 4K 60 frames per second, MIPI would be the only option. USB, if you want 4K 30 FPS, USB would be the next better option. And GMSL, you can go for 4K 30 or 1080p 60 is possible, but when it comes to GE, usually you won't get that much of bandwidth. For longer range, GE would be the better option. It can go for several meters. GMSL can go up to 15 meters. Then the USB, by default, it supports up to 1 meter, but there are cables which can support up to 5 meters as well. For multi-camera, MIPI would be the better option. Then the next better option is GMSL, because these processors provide multiple interfaces for MIPI cameras. When it comes to USB, if you connect multiple cameras, assume if you are going to use a surround view system, and if you want 4 or 5 cameras per system, if you connect all these cameras into the same interface, USB 3.0 interface, the bandwidth is going to be shared, and you may not be able to get enough frame rate from all these cameras. GMSL is just a conversion between MIPI and GMSL, so again, you can have multiple cameras with the GMSL interface as well. So now we know the components we need to consider before choosing the right camera. So how do we accelerate? How do you make a fast prototype and make it as a production-ready product? You can go for off-the-shelf cameras. So if you look at our product portfolio, we have a wide range of cameras in USB 3.0, MIPI cameras, GMSL cameras. You can choose the off-the-shelf camera, which already has an image signal processor inbuilt into it, and you have a wide range of interface options as well. To start with, you can go for a USB 3.0 camera and start your evaluation. These are UVC cameras. You can connect into a PC, and it can use the default driver, whether it is a Windows or Linux. It can work with the default driver. You don't need any additional driver for these UVC cameras. So that will give you an idea about what kind of image quality you are getting with this camera. And then if you want to continue with USB, you can continue with USB. And if you want to switch to a MIPI or GMSL camera, then it is possible. That all our USB cameras are also available in MIPI and GMSL interface as well. When it comes to Nvidia, one of the interesting aspect of Nvidia processor is that supports multiple cameras. It supports up to 6 cameras. In some cases, we can even have 8 cameras. And Econ systems provide multi-synchronized camera support for all the Nvidia platforms. One of the latest launch which we did is 6 GMSL camera for the Xavier platform. And we do have cameras for every single application. If you are looking for a global shutter camera, we do have an option both in monochrome and color. If you want to have a stereo camera for your AGV application, we do have cameras for it. If you are looking for HDR, GMSL, IP rated, IP67 rated enclosure cameras, we have the options. So this way, these are pre-certified cameras. So all our cameras are pre-certified, designed for certification. So you can use it as it, you can take it to the market as it is. You don't have to make any further development with that. Okay, that's it on the cameras. Now the processor. So we would strongly recommend NVIDIA processor for any edgeAI device. It is designed for artificial intelligence application. Jetson processor bringing power of modern AI, deep learning, and inference to embedded system at the edge. So as I said, it is designed for edgeAI, and you have a system on module for every application, be it a small facial recognition application or be it a fleet management application where you require up to 6 cameras, and you may have to do you may have to run your neural network in all the 6 streams. It is possible. You have options for all the applications. Let's look at one by one. So Jetson Nano is the most cost-effective, low-power Nvidia processor. It comes with a quad-core processor and 128 GPU cores. What it really means. So 128 cores. So with more the GPU cores, more better it is for the algorithm. And the floating point operation, that's an indicator for how powerful it is for inference system. So the more the flops, the better it is for inference. And Nvidia also have a complete ecosystem. So you can start your edgeAI application right away with the sample DeepStream SDK. We have a DeepStream demo at the end of the presentation. So you have a complete ecosystem, and the stack, the application stack, can be shared with all these processors. So if you develop an application on Jetson Nano, you can, if you want to move ahead with a higher processor, you can use the same application that will run on Xavier as well. So the software stack is exactly same for all the four processors provided by Nvidia. So when you choose a processor, look at the number of cameras you need. The Nano can support up to 4 2-lane and 3 4-lane cameras. So it can have practically 4 4K cameras. And also look at the encoder. Capability of encoder is also important when it comes to applications like remote monitoring or telepresence. So next best processor, better performance processor is Nvidia Jetson TX2. That has multiple cores, like 1 quad core and 1 dual core, and it is twice better in terms of GPU cores, and also more than twice better in terms of inference engine, the flops. And it can have up to 6 cameras. So there are customers, some of our customers are already in the field with 6 cameras, and all the 6 cameras can stream full HD at 30 frames per second. Then the Xavier NX and Xavier, these are the most powerful edgeAI platform available today. So it has a 6-core. The Xavier NX is one of the latest launch from Nvidia, which has 6-core processor and powerful GPU. Also, it has a 48 tensor cores, which is specifically for inference neural network. And it can have up to 3 4K cameras and 6 full HD cameras like Nvidia TX2. And it is pin-to-pin compatible with Nvidia Nano as well. So if you develop an application with the Jetson Nano, and if you want to upgrade it, if you want to scale it in the future, you can just use the same carrier board and switch to Xavier NX. And finally, the Xavier, edgeAI Xavier, is the most powerful embedded platform, and it has up to 4 4K. It can have up to 4 4K cameras, and as I said, it is having a more powerful GPU cores. So let's see how it translates into the application. Let's see some of the application and what kind of system we can use. So based on our experience, we do have customers in most of these applications. So for a telepresence or a facial detection or facial recognition application, the amount of algorithm, the horsepower needed for the algorithm is very less. And we can go for a cost-effective option like Jetson Nano. But in terms of, if it comes to smart surveillance or smart parking lot, you may need to download a lot of data from the cloud, and you will have to compare it. So in that case, you can go for TX2. When it comes to sports vision or multi-camera system, you can choose Xavier NX. One of our customers has integrated up to 6 cameras to Xavier NX. And for surround view system, example fleet management, you can go for Xavier. So you can have all the 6 cameras stream at the same time, and also you can run the inference engine on top of it. So how do you speed up? Now we know what is the best processor for the application. How do we speed up the prototyping and for the production? So just give you an idea, a rough estimate of how much time it will take for developing a career board. It will be at least 2 to 3 months. That's the minimum time it will take for developing a career board, and also you will have to take it for certification, and that is going to take further time. So we would strongly recommend off-the-shelf career boards, Econ Systems and CRG. We are partnered with Connectech, and we provide cameras for all the Connectech career boards. So you can use the Jetson SOM and use the off-the-shelf career board and take it for the prototyping right away on day 1. And then if the interfaces are good enough, then you can take it for mass production with the same career board and the SOM. You don't really need to redesign everything. But if you want a custom design either on the camera or on the processor, we are open for that. And we should be able to help you in customizing the platform. And Connectech has a career board for every single Jetson SOM. Okay. Now we know the hardware, and the important part is the algorithm. Over to you, Maha.
Thanks, Gomadi. Thanks for covering the camera and the processor section. So the key takeaways from what Gomadi shared is that you need to pick up the right hardware which is readily available from the shelf, where the camera is already integrated with the Jetson, so that you need not have to do all the hard work of making your camera work on this board first before you start your project, right? So that is the key takeaway. And of course, when you choose such a development platform, also make sure that these components which you are picking up also have a production-ready version. Like when you choose the camera and the hardware platform, the Jetson platform, are there production-ready equivalents which is available, so that once you achieve your goal of developing the algorithm, you could easily move on to your production. Perfect. So having covered the hardware part, let's move on to the algorithm and software part. So here there are a lot of different combinations that work on when you choose the software. There could be a computer vision algorithm plus an AI model in your solution, or there could be just a computer vision algorithm alone or an AI model alone. So there are multiple combinations which occur when you approach towards a solution. So for example, when you want to detect a circle, a computer vision algorithm is good enough. Whereas when you want to detect people, when you want to recognize people as based on their gender, then an AI model would be much more suited. And just solving this problem with vision might not be enough. And identifying a people, we could use a model, and then tracking them could be a computer vision algorithm. So there is a lot of combination of these algorithms and models which are present. Now, when we start working on this algorithm, there is an algorithm development part. Either you could start from scratch and do it, or you could pick an existing algorithm or model and see how it works for you, and then optimize it, improve it. If you choose a model, then you prepare your own data set and train it before applying it for your final solution. So the algorithm development or going towards a solution with existing blocks is not always a very straight path. And once you do all this, okay, you have made everything work. There are a lot of other things when it comes to final productization, putting it on the edge, optimizing it for working with live stream of data and things like that. That is another thing that we need to consider when we are choosing these algorithms and blocks. So how do we start, and how do we go towards a fast prototyping of all of this? That's where Nvidia's Deepstream helps us, where Nvidia has a framework to help us get started on this AI journey. And from VisAI Labs, part of Econ, we also have a VisAI platform which has a collection of algorithm accelerators which can help you go forward as well. Let us first see how Nvidia's Deepstream helps us get started with our AI development. So what is Deepstream? Deepstream is a flexible and scalable SDK with the building blocks for rapid prototyping complex AI solution from edge to cloud. So wherever Nvidia's GPUs are present, you could develop a model and that could work right from the edge to the cloud. Of course, they would have limitations based on their computing power, but you could use the same development tools to work with an AI model right from the edge to cloud. So that is Deepstream. So what isn't Deepstream? Deepstream is not like a one-size-fits-all solution where you can just take an existing example of Deepstream and go for production. So we have to understand that this is more of a development tool which makes our life easy to build algorithms, but not an algorithm in itself that you can pick and put it into the market. So I might be repeating this not a one-size-fits-all very frequently, because the problem with AI and the problem that you're trying to solve with AI is not a one-size-fits-all. Like, you cannot make one model that works for every situation. For example, if I make a model to detect people, it might work in one particular angle of the camera with one particular conditions and field of view and the distance from the people and the camera. There are so many things that are connected to this working efficiently. And when I'm using the same model for a different field of view where I see more number of people, then I may have to train that model for that particular situation. So that could be optimization, fine-tuning of the model, and retraining of all this might also happen. That's why we always say that solving this AI problem is not a one-size-fits-all. Now, when I said Deepstream is a framework, right? It's an SDK which makes our job easy. So where does it help? When you connect a camera to an Nvidia platform, you need to take the frames from the camera to your RAM, and then you may have to pass it through your engine where you do through your inference engine, where the inferencing is done for your AI model, and then you have the results out. And you may also have to take the video stream and stream it out to another server or maybe to the display. And you may want to overlay your results on top of the screen. So how do you connect all these different blocks of hardware, of software? How do you take the stream to the memory, and how do you pass it on to your inference engine? And then how do you work with your results? Connecting all this with Deepstream, it makes your job very easy to connect this from end to end. And Deepstream has like very clear examples of how this is done, which you can download freely from Nvidia, and you can try and you can use. So Deepstream has a place where you plug in your models, and Deepstream has some sample pre-trained models for evaluation as well. So you could find a list here which we have put, like PeopleNet, TrafficCamNet, Face Detect, IR. All these are models which Deepstream has given as samples so that they can demonstrate how their framework will work. So this is a good starting point for anybody who wants to explore AI on Nvidia platform to begin with. So what does VisAI platform offer? So VisAI platform offers algorithm blocks or algorithm accelerators. So we have done work and we have created some blocks like people counting, congestion detection, social distancing checkers. So these are blocks which we have trained, and these are models which will work with Deepstream, and we have trained this for a particular data set. And if anybody has a requirement for people counting for a different situation, these models can be retrained or can be used for their applications as well. So this is what we call as algo accelerators. And if these are mainly used for people who do not want to develop the algorithms from scratch, Rather, they have a requirement and they want to pick something which is existing, which is available with us, and which we can fine tune for your final use case. Okay, so now we have covered the hardware parts, and we have also covered the algorithm parts of where you could pick your algorithms from and how you could start, right? So I'm just giving you as a developer, as an engineer, if you're going to start your first edge AI development or a product development, how will it look like? So in broad terms, this is how it is going to look like. You have to go in and pick a board, development board, which has the Jetson as well as the camera inbuilt, and then choose a model that you want to work with. So for example, if you're going to do people detection, it could be PeopleNet or YOLO from the open source. So you pick up a model, AI model, and then you work with it. You first evaluate it on this platform to see how it works and how it works for your particular use case. And obviously, it's not going to be a perfect fit. It will not work 100%, but you will be able to appreciate some of the algorithm working, and you will also see where it is lacking. So that is the time when you go ahead and tune this model for your requirement. You have to figure out what is not working, then tune the model accordingly, and also train the model with your database so that it starts bringing in the accuracy that you require.
So the first thing that you have to start with is making a proof of concept. Have a goal for your algorithm, and then see how much you can get there with your dev kit, an existing model, and a camera, and then fine tune the model or the algorithm. And if required, if you understand that it is going to be a big problem, or if this particular existing model is not going to solve your problem, then you could go ahead and think about designing your own model and trying to resolve the problem. Because in most AI cases, an existing model with fine tuning and training it with the right kind of data is the final solution for most of these applications. And once you have a proof of concept which works to your requirement and it works to your accuracy levels, then you could go ahead and design the final product or solution. So before we close this webinar, I would like to show how the first two steps are done, and I'll show you a video of how we did it. Like choosing a right development kit, a hardware and a camera combination, and then using an existing AI model. Okay, so I'll show you a dev kit. So this is a Rudy NX kit, which has a Nvidia Xavier NX inside it. And this is from Connectech. And we have connected our SturdyCam, which is a rugged camera, which has connectivity over GMSL to the Rudy NX box. So once we connected this, we attached this to a vehicle and we took it out on a ride to a road so that we could capture the video, and we could also do some live inferences. So if you order such a kit and a camera, once you get it, you can use Deepstream and run one of its samples in like 2-3 days. So that's what we did here, and I will show you how that looked at first. Okay, so please be aware that the video I'm going to show has Deepstream working on it, but again, it's not an optimized or a ready-to-use application that we are showing. So we are showing what you would see on day one of your development. So the reason why we are showing this is to emphasize that this is a great starting point. So you have a starting point where you have a model which is working, you have the camera and the hardware, everything with you, so that you could start your development from here. So let's watch this video.